So welcome back to the final, probably the final episode of the monoblock quad tube amp series. Um, I just wanted to showcase the final results of the design and give you a preview of, or give you a view of what it looks like. Uh, there's still some tweaks to do with it. I may change the bandwidth a little bit of the low pass and some other things, but all in all, I'm pretty happy with the build quality, with the way it sounds, and with the way it works with my existing stereo system. So the initial design concept of the recessed tubes with the subplate worked quite well. I'm pretty happy with the results of that. I think the design looks pretty neat, very clean. As you can see, there's no hardware for tube sockets or anything like that on the top surface here, so you have a very clean design up front. There's a bit of hardware here showing, and the labels on the transformers and the plain, I guess you could say, 632 hardware holding the bell ends together on the transformer. They are somewhat jarring, but I mean, I can get black anodized number 6 hardware and replace this with that, and that will clean it up a little bit. The labels, I might just keep them. It doesn't really bother me, but I suppose for a slightly cleaner look, the labels could be maybe replaced, removed, or maybe even moved to the bottom of the transformer, or placed somewhere else, maybe on the bottom of the component system for later reference. The color of the wood trim, this is Paduke with just an oil finish on it. Matches the black of the top paint job very nicely. And the gold trim on the knobs, I think, is offset quite nicely from the red of the Paduke. Paduke is a kind of a challenging wood to work with. It's very oily and it's very chalky. When you are cutting it, you get a lot of fine red powder. It's almost like red chalk dust. So it's a challenging wood to work with, but it's a very beautiful wood when it's matched up against black or brown, and you get some very nice contrasts with it. It's a pretty wood for trim. Using it for any sort of major wood on a project, it would be very troublesome to do. The rear of the unit, here we have the IEC connector, the integrated fuse and power switch, the output, and then the RCA jacks for the left and right input and the pass through. These are just connected together across, so it doesn't really matter which pair you use for the input and which pair you use for the bypass. On the trim on the edge, you notice a couple of the wooden keys here. This is walnut, and I just used those to reinforce the mitered edges. Later on in the video, you'll see a clip of how I did the mitering, and how I worked with some clips on how I worked with the wood, and I think I also have a clip in there on how I put these mitered keys in to strengthen the wood. On a normal glued mitered surface, it's very weak because it's all, the end of the wood is glued to the end of the wood, and that's not a very strong joint. So you have to do something to reinforce that joint. you either put a mitered key in this way through the joint, or you use this technique to create a bonded joint by using this wood as a way of getting grain to grain glue surface for additional or increased bonding. It's pretty tight. As you can see, I've got all the wiring done. For the transformer wire, I try to keep as much of it as I can in case I want to remove that transformer and use it in another project. I don't like cutting the wires off close to the end. So some of these wires are actually tucked in below this low voltage power supply to just get them out of the way. And the wire is then just has a heat shrink cap put on the end of it so it doesn't short out against anything else. These feet are temporary. I've just put them on here for testing, and there's going to be a bottom put on this chassis at the very end to prevent any heating of internal elements from damaging the surface that this is put on. The preamp board and tone shaping board is pretty tightly integrated in here. There's not a lot of room, but I haven't noticed any appreciable noise caused by it being put there. I used a coax cable to bring the rear line inputs up to the front and tie them into the board. This is some stuff I had lying around that I picked up from my work. It's very nice coaxial. It's actually used for high frequency, 4 gigahertz and up. But it's it's free, and it's rather than it going to waste, you can just put it in a project box. It is very heavy. I'll have to say that. With the 2 transformers on there, this is a hefty little beast. If you notice, or if you can just make out a little bit of gray down here where my finger is, that is the sill pad that I used to press between the transformer backing plate and the top surface of the chassis. This acts to transfer heat from these high power resistors through the plate and then up to the top chassis, and then actually eventually even into the transformers to increase the cooling capability of the system. When it's turned on, and I've had it running for like an hour just to do temperature testing, the lifting up the front of the case and just feeling the top of the surface where this is resting on is completely cool. There's no heat being transferred from the inside down to the surface that this is resting on. So I can only ascertain that the air cooling system that I kind of designed into this is working to some extent. So cold air is being drawn in around the edge of the chassis, heated up by the interior of this, and then that hot air is coming up through these clearance holes around the tube. Also the air around this area is also heated up as the tubes operate. So that air is going to rise, and it's going to help to draw the hot air inside the box up through those holes. How well this is working? Well, only long-term testing can really show that, really. A final observation is that I found that when I connected up the virtual ground for the 6.3 volt heater circuit, it didn't really make much difference. There was not a lot of heater hum in the system. and I can only attribute that to the push-pull nature of the outputs. So I think what is happening here is there is a cancellation effect being caused by the fact that both the upper and lower tube in the push-pull circuit are being heated with the same AC pulse. So as the AC turns on and off through its sinusoidal power curve, you'll get a pulsing effect that can be translated through into the circuit, into the signal circuit, and cause a hum. That effect is kind of canceled out because there is a tube on either side of the transformer that's doing the same thing. So when you sum them together, they cancel each other out, and this is essentially how differential circuits work when you're trying to reduce noise on long lines, like in automotive circuits. For example, CAN bus is a differential signaling system, and that's how it reduces the noise that could be coupled into wires. This noise reduction effect is referred to as common mode noise rejection, and I think that's what's happening with this circuit. So I don't know if I'm going to do much more in this series. I can post some information on the schematic if people are interested. I can talk a little bit maybe about how I tweak it. One thing I'm going to try to experiment with is this, I believe, is a 6AU7. I'm going to try a 12AU7. I'm going to try a 12AX7 in here to see if the higher gain will give me a little bit of improved boost to the output. I am noticing that the sound quality is a bit low, and I have to sort of boost it up quite a bit. This could also be because the 3 dB point in this thing is around 110 hertz. It's very low. This material here that I'm showing some pieces of is the sill, I think it's a sillastic or sill pad, I think is the product name for it. It's fairly thick, this stuff. This is about 1/8 of an inch thick, and it's very pliable. It's kind of like silly putty, if anybody remembers silly putty. It does return to its shape, but you can it's very easy to deform its shape and compress it between mechanical components to affect the heat transfer. This stuff is designed and cut for applications. I got this material out of an old Dell power supply from a rack mount computer. These company was throwing those things away, and I just take them home and I disassemble them, take some MOSFETs out of them, and also get this sill pad material. It's very handy for this type of situation where you want to mechanically couple away heat without affecting any sort of electrical properties of it, because of this stuff is actually not electrically conductive, it's just thermally conductive. So I'm going to show in the next scene it playing and integrated into my stereo system. Just to explain, I have a stereo Class A or single-ended EL34 tube amp that I'm using for the main sound channels. And then this new device, the new bass amp, will be there to enhance it. For the speaker on the bass, I've just cobbled together an old subwoofer speaker that I'm using for testing. It's not an ideal solution for a final one, but it works for the demo purposes. You'll notice the audio will be a little bit low. It's just the nature of the microphone equipment I have here and the effects of the room. In person it sounds really well, really good, and I'm pretty pleased with it. So, hope you enjoyed the series, and let me know if you want any additional information on circuits, or if you want to be able to download the circuit or try it out yourself. If I get any interest in the comments, I will be happy to provide some free information through like a Google Share link or something like that. And that's it for now, and hope everybody's doing okay, and take care. Bye.